Welcome again. We continue with inverse normal distribution. We're looking at the probability that x will lie between 32 and an unknown upper limit, and we're told that that probability is equal to 35. We need to find the unknown upper limit that would correspond to that result. We're told that x follows a normal distribution where the mean is 35 and the variance is 16 or 4 squared. So let's have a go at diagrammatizing the information that is presented to us. So we have 32 and k, and then the area in between is 0.35. So essentially, the probability that 32 is less than x is less than k equals 0.35. We know here, in terms of how we would ordinarily go about working this out, we would do the probability of x being less than k minus the probability of x being less than 32, and then we will get set that equal to 0.35. So let's rearrange it and let's do a probability algebra problem. Or set up a probability algebra problem. So we have the probability that x is smaller than k minus the probability that x is smaller than 32, that would be equal to 0.35. So therefore, the probability that x is smaller than k must be 0.35 plus the probability that x is smaller than 32. Once I've written it this way, I can simplify by evaluating this expression, x smaller than 32, and I can use the calculator in order to assist me here. So I would go to statistics, distribution, choose normal, NCD. So my lower is going to be an arbitrarily small number, so minus 1,000. My upper would be 32. My mean is going to be 35, and my standard deviation is going to be 4. So let's go to our calculators and sub in those values. So again, statistics, distribution, normal, NCD. My lower is negative 1,000. My upper is 32. My sigma is 4. And my mean is 35. So I should get 0.22662 for that bit. And when I simplify that, so 0.35 plus 0.22662, and that gives me 0.57662. So now I can deploy the technique that was previously introduced, where I now use a calculator again and use the inverse normal to solve for the k value that's associated, or the unknown x value, that's associated with that probability. So I would still be statistics, distribution, normal, inverse normal, and then area, which is the probability that is leftward facing. So we know we can use 0.57662, and then mean is 35 and standard deviation is 4. So if you're doing this problem without a calculator, it is really quite challenging. So distribution, normal, inverse normal, area is 0.57662, sigma is 4, mean is 35, and therefore K is going to be equal to 35.773. So that, in my opinion, is the most straightforward way to approach a problem. All right, so we can note the value for K, 35.773. Now we can try to do this problem using a tabular method, but again, it's going to introduce some inaccuracies because we're going to be approximating the X score that's associated, or the Z score that's associated with the probability value, since we won't necessarily get bang on with the probability value. All right. So let's have a look at this from a tabular perspective. So using the tabular method, we would maintain everything as is, and then now we're going to work out what's the probability that X is smaller than 32, and then continue from there. So the probability that X is smaller than 32, we would convert that to a Z score. So it would be the probability that Z is smaller than 32, take away the mean, which is 35, divided by sigma, which is 4. So this is equal to the probability that Z is less than negative 0.75. All right, so here, if we do a quick sketch, negative 0.75 is going to be identical to positive 0.75. So the probability that Z is smaller than negative 0.75 is equal to the probability that Z is larger than positive 0.75. But now we want to use the complementary probability fact to help us here. We know that this is going to be identical to 1 minus the probability that Z is smaller than 0.75. So we would go to our table and find the corresponding probability. So 0.75 corresponds with 0.77. So this is 1 minus 0.77337. So once we do the subtraction, so 1 minus 0.77337, we're going to get 0.22663. So this is the same as 0.35 plus 0.22663, and that gives us plus 0.35. That will give us 0.57663. So again, now we would continue to use the Z statistic approach in order to now solve for K. So let's erase this. So the probability that X is less than K now becomes the probability that Z is less than K minus mu over sigma, which is the same as the probability that Z is smaller than K minus mu is 35 and sigma is 4, the standard deviation. All right, so all of that must equal to 0.57663. So we would go to our table and try to get as close to 0.57663. So K minus 35 over 4 is equal to phi inverse, that's our inverse normal, of 0.57663. So we look for 0.57663, and we're going to get between 0.19 and 0.20. So 0.19 and 0.20. So when we're working this out, we would use 0.19 as the appropriate value. And then let's just check the actual value. So I'm going to go to distribution, normal, inverse normal. The area that we want is 0.57 663, and then sigma is 1, mu is 0. So the actual value is 0.19327. So using the actual value, we're going to have K minus 35 over 4 equal 0.19327. So K is going to be 4 lots of 0.19327, add 35. And then when we work out that, 4 times 0.19327 plus 35, that gives us 35.77308. All right, and that compares favorably with the answer that we had from before. All right, so that concludes this presentation.